Hello, we will present now the work Deep Symbolic Processing of Human Performed Musical Sequences. We come from the Instituto Politécnico Nacional and the Center for Computing Research. We are a team consisting of Naum Carlos Alexis Rangel and Salvador Godoy Calderon, and finally, myself, Iram Calvo. Thank you very much for attending this, and also thank you for inviting us to the LKE 2021. So we will cover the following topics. First, a general context and practical motivation. Then we will present the state of the art. Then we present our proposal, our experiments and results. And finally, we draw our conclusions. So as a general context, there are many musical activities. To learn to play an instrument, we need to listen, play, and compose, analyze music, analyze scores, in general, a lot of activities. And all of them are guided by the musical notation language, which is an open-ended domain, by the way. So we have, on one hand, semantics, which are ambiguous because the meaning of a note can represent a lot of different ways of playing it, and syntax that is well defined. So in this work, we focus on finding the binding between both of them. Musical activities have the following consequences. There isn't a unique correct way to perform a musical sequence. Maybe we can put some kind of emotion in it, stress some notes, and a lot of things that are not in the score. Also, it is difficult to determine errors and to assess their magnitude. And this is where we want to create a tool for aiding in this part. From the AI perspective, an important task is to emulate intelligent behavior within an ambiguous semantic context. And this is why this task is interesting from this perspective. In practical motivation, when we are learning to play a musical instrument, we need supervision from a tutor because sometimes we are playing and we are not aware of the errors we are doing. So tutor supervision is essential during student practice time. So it will be nice not to depend on a human being, not because we don't want, but you need a lot of time. When you're practicing, maybe you will practice 5 hours a day, and it's very difficult to have some companion that will resist hearing your mistakes like 5 or 6 hours a day, right? So it would be very nice to have an artificial tutor that allows us to correct our mistakes without having someone present at that time. So our goal is to develop an artificial agent capable of identifying and causally characterize execution errors during the execution of monophonic musical sequences performed by humans. So please note the limitations we have here. One of them is that sequences should be monophonic. In the future, maybe we will cover more complex musical sequences, but as you will see, this is complex enough to begin with. So to but some of the limitations from the beginning, well, we said already, it should be monophonic, and particularly we will focus on transversal flute. We will not study the acoustic signal as it is. However, we will focus on the symbol processing after the initial translation. We will detail this in the next slides. And also, it's not our objective to construct a complete intelligent tutor, meaning that there is this is not a tutor that will guide you and tell you, please repeat this sequence again. And maybe, as I know already that you can play this sequence very well, then maybe we can go to the next sequence. This is not the goal of this work. However, in the future, this work may be used for this purpose. Here we will only propose a module for error identification and characterization. So what is the state of the art? There are several scientific papers, for example, from Nakamura, Saito, and Yoshi, Statistical Learning and Estimation of Piano Fingering. You can see this is aimed to piano. Then the second one focuses on aligning audio to score, which is also a complex task. The third work is devoted to reducing octave error in pitch detection. We will see this is very useful because when we are playing an instrument, we can create harmonics which interfere with the pure sound sometimes we need or we want. The fourth work is performance to score sequence matching for automatic ornament detection in jazz music. So you can see all of these are related to what we want to to performing this work, but are not exactly the same. Also, there are lots of conference notes, fortunately, but also they are not focused specifically on the problem we have just laid out. Hierarchical approach to detect common mistakes on beginner flute players is one of the closest ones. The second is the potential for automatic assessments of trumpet tone quality. And the third one is evaluation of the technical level of saxophone performers by considering the evolution of the spectral parameters of the sound. You can see that these works are published by the Society, International Society for Music Information Retrieval, and this is their conference. They had several issues in 2006 and 2014, 2011, and they are focusing particularly in music information. However, they are not dealing with the symbolic information we need to work with the transversal flute. Also, there are lots of books on this subject. For example, the first one, Artificial Perception and Music Recognition. The second, in Readings in Music and Artificial Intelligence. And the third one, Music Education and Artificial Intelligence Approach. These resources focus mostly on the tutoring part, than identifying particularly the nuances on a bad execution of the instrument. So our proposal in particular has to do with a taxonomy of errors. Given an error, we can consider it's a solfege error, meaning that we are having a mistake in the tone, duration, sequencing, or maybe the dynamics, which are also bounded to the ligature, volume, or pace, meaning that we are not reading properly the score or the sheet of music. And another kind of errors have to do with the sound quality that we have, for example, background noise, as the one you have just heard, or sound impurity, that we have incorrect attack or decay, and also maybe because of the recording, or maybe because we are actually not blowing the instrument in the case of the flute correctly. So what will we do with this error taxonomy? Well, we want to detect them all. And how? Well, first we focus on the transversal flute because it's a monophonic instrument and also has a 3-octave range. And we will see also that it's very important that we reach this range by having different strengths of blowing, meaning I can blow very softly or very hard. And with depending on the energy of this blow, we will find or we will hear a different note. And it's tuned in C. The proposal consists of an architecture of interconnected cascading layers of symbolic processing of a musical phenomena. This is why we are saying that it's deep symbolic processing, because we have several layers. Usually we are used to hear deep learning with lots of layers in a connected architecture like neural networks. But to be deep, you don't need to have layers of neural networks. We can also have a different way of deep architecture whenever we have lots of layers. So we will see here we have a considerable amount of layers, each one of them devoted to a particular issue in this work. So each layer solves a part of the whole task and applies its own local criteria of semantic flexibility. And it will be also very interesting that we can tune each one of these layers so that we can obtain particularly what we want for this layer. The working hypothesis is that the accumulated effect of those layers approximates the behavior of a human tutor by identifying errors. So let's go so that we can explain better this part. This is the architecture. We have as an input our notes in a diagram, a pentagram, and we record them by using a computer. And then we have both a transcription directly from the from this file, which we are not performing OCR or something like that. For that, we have another work, but it's not the case of this one. We assume we have this information already from a MIDI file, for example. On the other hand, we will have this representation which has to do with the sound wave. So we have both a reference and what is actually played. That, as we said before, they can have a discrepancy. They can be different. The second layer segments this part, and this fits the segmented played sequence for a sequence analysis. In this third layer, we will find discrepancies between the reference and the played, the segmented play sound. And then we are able in the fourth layer to identify errors. These errors are identified, and then we have some rules to determine the cause of these errors. As we say before, maybe we are not having enough air, we are not blowing strongly enough, or maybe we are not breathing correctly, etc. We can determine the cause in this layer. And finally, errors are returned by this layer and also the error causes. In layer 1, we have the chromogram, which is automatically obtained from the signal. And from here, we can have both the solfege aspects that have to do with the tone identification, meaning the rows. When we have a higher row, we have a higher pitch. And also, to identify silences, well, we have these gaps, for example. And maybe we are doing some silences that are not related to the original sequence. Maybe the original sequence has no silence indicated and we are performing it for some reason. And also duration. And this is a common error, as we will see, that sometimes we exceed by some milliseconds the duration of the note as it should be. Also, we have some sound quality aspects that we already outlined before that have to do with the energy fluctuation and have to do, for example, here we can see the different colors. The ideal note, of course, is not reachable by this instrument, but the ideal note should be all the same energy. This is not the case in most notes. Also, the tone purity, which has to do with how much spanning has this note. You can see, for example, that this note has spanning in these harmonics above and below, and also here. Here we have kind of an echo. This is called harmonics. In this note, we have also these same effects, the same effect that the purity of the tone is not complete. And also with this instrument, we won't have 100% purity, but if we are playing it not correctly, we will have more noise than should be. And also the layer number 2, once we have identified these with the chromogram, we'll have the reference that we said we already had, which has to do exactly, is the same representation, the symbolic representation from the score. And here we have just by numbers and numbering each note from 0 to 6 and what we actually played. And you can see this is a very interesting step because now we are working completely on the symbolic side. We will do symbolic comparison only. We can forget for now from some energy, from harmonics and everything. Why? Because we have already identified in symbols the additional silences, that maybe the notes that are not correct. For example, you can see here that when we should play a mi, we are not playing it in this position. However, we are inserting kind of a C note. Where those C note comes from? Well, because maybe I am not digitizing pretty well in the flute, so maybe my fingers are not moving correctly, and because of that, I am introducing an additional note. But you can see we are introducing additional notes, we are missing some notes, and we are also adding some silences, and this is what we want to find. So this is this layers work is crucial for the next layers. In sequence analysis, once we have the original reference and the actually played sounds, we have, you can see these numbers are millisecond, then we know there are some tags that we have found here, which, what are the discrepancies? We have the synchronized notes, we have difference of duration of the note, we have some time before extra note, etc. So we are characterizing each one of the discrepancies in this layer to be fed into the next layer. Then we are able to name the errors from these discrepancies. For example, given these discrepancies, we are able to say, okay, we have a duration error, a sequence error, maybe a background noise error, a messy attack, an interrupted note. So you can see how we are building the error identification from the beginning and we forgot from the original representation of the nodes. And finally, we show exactly where these errors appeared. We have here the offset. For example, if it's a duration error, maybe I had a 0.09 seconds extra, or maybe when it's negative, it should be longer, the node I played, but I didn't. Why? Probably because I had a messy attack. So also please note that we have combinations of errors for each one of the nodes. These 0 to 6 go or are corresponding to exactly the numbers of the nodes we saw at the beginning. So we are saying for this node, you did this and this and this error, right? And finally, as we promised before, we want to say why. Why are we having this error? Well, maybe if my error has to do with tone, duration, or sequences, maybe I wasn't able to see correctly the node and I played by mistake, or maybe my lips are not moving with the correct dynamics, the correct pace. Sometimes we are moving fingers and they are not synchronized with my lips, right? So all these problems can happen. Or maybe the embouchure, which is the thing that goes here, the embouchure is not correctly attached to the mouth, then we can have an incorrect attack decay because air is going somewhere else, not inside the instrument, or interrupted sound. Or maybe, as we said also, we can have a problem in breathing technique because of the sound impurity. So given these errors, we are able to identify the causes of each one of them, and this is what we return to the player. Okay, so this sounds quite good, I think. So in practice, how good is this working? How well? Let's see. We proposed 4 testing sequences. Actually, we proposed a lot more, but we focused on these 4 because they are interesting. For example, the scales of Garibaldi, because they have to do with correct movement of fingers, the digitation. The second one is of intervals proposed by Tafanel. And we have some movements that are particularly difficult or that we need to repeat several times in order to have a good execution of the transversal flute. And also we proposed, particularly by the CIC IPN, some solfèges, which maybe if you can read these sequences, you will hear them a bit strange, and they are. And this will have an interesting effect when we present results, as you will see. And solfège number 2, which is a little bit similar to scale, but mixing silences. This is interesting because we need to have a good breath control in order to stop when we have to stop, and also digitation, which the scale hadn't. The scale hadn't this issue of mixing silences with the scale, and solfège number 2 does. So this is why we chose these particular testing sequences. Let's see how our performers performed. We have 12 players. 7 of them recognize themselves as intermediate. Why? Because they are studying their instruments and they don't have too much experience playing them. And also we have the rest of them as advanced, from 8 to 12. We have 5 advanced players, and well, we can say they are advanced because they have lots of experience, long time playing the instrument, etc. So let's see. I won't go deep into these figures because we don't have enough time, but you can check all of them in our paper. So in the subtotal, you can see that in general, we should expect that the solfège errors are smaller for the advanced than for the intermediate. And it's the case in some cases. For example, number 10, which labels himself or herself as advanced, has more errors of solfège. And also the same happens sometimes for sound quality errors, but in general, there is a tendency here for the sequence number 1 to have less sound quality errors for the advanced ones. So we can say that an advanced player will have less sound quality errors than an intermediate. And for, well, we can see also this as a figure where we can see from the right side that advanced errors are lower. The same we will have for sequence number 2 In general, the behavior is the same. Also, you can see by this graph that the right side, delimited by this dotted line, is smaller. Of course, you will find cases where maybe this 71 from advanced 3 is a greater number than 73 from intermediate number 3. But in general, if we have an average, we will find for sure that advanced players have less number of errors, both in solfege and sound quality. For sequence number 3, we have a similar behavior, maybe in this case, not so markedly. Remember that when I presented to you sequence number 3, I told you it was a bit strange. Well, it's not strange only for us. Let me go back to the notes. Maybe it's not so strange only for us, but also for players. Why? Because this is difficult to play even for advanced flute players. Why? Because they say, I don't even find these kind of sequences when I am playing a very complex melody in flute. So they really do not have practice in these strange sequences. So the results that we are finding, that errors in total are almost the same in this case. Also, we can find a tendency, right? But for advanced ones here, we can find more errors than for other sequences. And finally, for sequence number 4, results normalize. Why? Because they say, okay, well, I know how to do the digitation, a correct digitation, and also breathing. This was not big problem for them. So also, this stresses that it's very important. Then this is very important that the exercises that are proposed for measuring the correctness or the expertise of the players are not the same always. Results will depend on what are these sequences. Okay, so this is part of our conclusions. Also, we can conclude that the most common mistake among all performers is duration error, both intermediate and advanced. Of course, advanced performers have less time differences. However, if we compare sound quality and time, we will find that in general, time is an issue for all performers. The second one is neither of the performers in the respective groups is clearly the best. Why? Because there is no single performer that had all the exercise better than the rest. Why? Because maybe performer number 3 had exercises 1 and 2 very good, but failed in the third and fourth ones, even if he is an advanced one. And this does not mean that he's not good, right? But that the characterization of a player is not so straight. And it is necessary to carry out the experiments with more test subjects, of course, to be able to characterize them. And as you can see, we are presenting only intermediate and advanced. What would happen with beginners? We want also to identify each group, but this is left as future work. And why were these sequences not presented to beginners? Well, because they would be extremely difficult for them. So we tried, we even had some kids and told them, play this, and they have been studying for several months, the transversal flute. And well, no, we don't want them to make them suffer anymore. So also we need to design more sequences that are able to characterize beginners, intermediate, and advanced players. So in general, our research conclusions are, with the obtained information, it is possible to correctly identify tone errors, duration errors, and some other related to interpretation aspects, such as attack and dynamics. Remember that we, from the beginning, converted our domain of study to symbolic processing. The proposed solution, as well as the interaction with some experts in flute execution, allows to create a knowledge base to characterize the most common errors in monophonic musical sequences. Why? Because if we study the general sequences that are used for practicing, we can say, well, beware of this, take care of this thing. Maybe you are not moving this finger correctly, and errors will be personalized because not everyone has the same mistakes as we have seen. So this is all. Thank you very much for your attention. Thank you. And if you want to contact us, please check our emails at the at our paper. Thank you very much.